What causes the seasons on Earth? Okay, that was kind of a hard question. Let's start with an easier one. How do you know when it's summer? Days get warmer and longer, right? Heat and more hours of daylight are not just signs that summer is here. They can also help us understand the reasons why we have seasons on Earth. We'll start by looking at the issue of heat. Why is it hotter in the summer? Well, days are longer, and longer daylight results in more time for the sun's energy to be absorbed by the land, water, and atmosphere. Longer days can make it hotter. However, the longest daylight in the summer in the northern hemisphere is in Canada and Alaska, where they have about 23 to 24 hours of sunlight. And the hottest summer days are in the southern United States and Mexico, like Arizona and New Mexico and Mexico. There's got to be more to the story. All right, I'm going to do an experiment for you guys today. We've been talking about why is it hotter in the summer than it is in the winter. So I want you to look at, I'm going to use this flashlight to represent the sun. So the sun is an energy source. This flashlight is also an energy source of light. And this is a beam of light that we're shining at the ground here. So right now I'm shining this flashlight straight down onto this board. And you can see that the light forms a pretty bright circle. So I'm going to put a circle there where we see the light from our flashlight as it shines straight down. Okay, now I want you to look at it as I tilt this light and how that changes. So I'm tilting the light, and now you can see that the light has become more spread out and it's not as bright. And now it goes out kind of like that. Okay, so we go from having a bright, focused beam of light to when we tilt it, it's much less focused and spreads out in a bigger area. Light is a form of energy. The flashlight from the experiment and the sun are both sources of light energy. I use the flashlight to shine light energy on the floor. The paper from that experiment shows the area that the energy beam covered at 2 different times. You'll be completing an assignment called Solar Angles. The first 3 questions on that assignment can be answered by viewing the flashlight experiment that I just showed you. Energy travels from the sun to the earth as radiation. Radiant energy travels in rays. We learned that last quarter when we talked about waves and we talked about light waves. The number of rays hitting a given area is the energy concentration. So when a lot of rays hit an area, the energy concentration is high. When just a few rays hit an area, the energy concentration would be low. Let's focus in on this resource here. The flashlight in our experiment puts out a steady beam of light rays that's about 5 centimeters across. The angle that sunlight strikes a surface is called the solar angle. So in that experiment I talked about how the part that showed just the circle was straight down, and then we tilted it. So when the flashlight beam falls on a surface from directly above, it models a solar angle of 90 degrees, and that's what we're seeing right here. And the area it covers is a circle about 20 centimeters cubed. Don't really need to know the math necessarily, but we see kind of that here. Here's the circle. When the solar angle changes from 90 degrees to 15 degrees, which we're seeing up here, what happens to the size of the area the beam falls on? The shape changes from round to oval, and we saw that when I tilted the flashlight, and the area that the light falls on gets bigger, but the amount of light coming from our flashlight is the same. These low solar angle rays are hitting Earth's surface at about 15 degrees right here. These light rays shining from directly overhead have a high solar angle. You see that right here at 90. It says high down here as well. They're hitting the Earth's surface at 90 degrees. The incoming rays of light are equally spaced in both beams, so it's the same light that's showing up. But because of the difference in the angle of the sun, if we look here, 3 times as many rays are showing up in the same area as when we have a tilted angle. Up here, we only see 1. So 3 times as many rays are falling on a particular patch of the Earth when the light comes in at a high solar angle. If it comes in at a low solar angle, we don't have as much. The concentration of energy is greatest when light shines on the surface at a 90-degree angle or from directly above. A light beam covers a larger area when it hits a surface at a smaller angle. So think about this. If you took a spoonful of jam and put it on a piece of bread and just plopped it on there in one spot, it's all concentrated in that one little area. If you took a bite of that area, you'd have a whole lot of jam. But if you took that same jam and spread it all over the piece of bread, it's still the same amount of jam, but when you take a bite, the jam isn't quite as concentrated. And so we see that here with the sun. So here, it's when we just take a big plop of jam and put it in one spot. And over here, it's not as concentrated. It's spreading out over more area. So here's a little diagram of what sunlight looks like as it's hitting the Earth. So here is our planet. I've placed our little guy right here about around where California is. It says the observer latitude down here is 38 north, and that's about where we are in Jackson, Placerville area. And you can see it's March, and the light beams are hitting the planet directly, and here's where the sun is showing up right here on the equator. Okay, so that's kind of the significant thing about March, is that the sun is right on the equator. So let's watch what happens as we go throughout the months of the year. So I'm going to start this animation. We're starting in March. Okay, you can see that as we move towards summer, the Earth is actually moving in its orbit. And you can see that the sun's rays are coming in at a different angle, but they're more focused on the northern part of the hemisphere here. You can see the sun moves up to the Tropic of Cancer, and therefore, because I'm going to pause this simulation right here, you can see that the light rays are hitting the northern hemisphere at more of an overhead or that direct angle, the high solar angle. So what happens is we keep going throughout the year. So now it's July, August, the sun's rays are starting to kind of head back towards the equator. So now these rays are kind of elongating as they hit the northern hemisphere. And we're moving into fall, but if fall in the northern hemisphere is spring in the southern hemisphere. And you can see the sun is moving down to the Tropic of Capricorn. And now those rays, I'm going to pause it right here again because we're in about the end of November. Those sun rays are directly hitting the southern hemisphere, but up here in the north, we're getting more of that low solar angle, like the 15-degree angle. Since the Earth is round, the angle at which light hits Earth is different from place to place. Light doesn't come to the Earth from different angles. It all comes from the sun. Light strikes surfaces that are at different angles. So if we look at this picture, you can see we can think of Earth as many flat surfaces. And we've kind of shown that with this black, many-sided shape around the planet. So remember, the angle between the incoming rays of the sunlight and the surface of the land is the solar angle. So if it comes in at, let me get an arrow here. If we come in right from the sun like here, that's going to be a high solar angle right there. It's hitting it at a pretty high angle. But if we came in at a different, like here, think about this angle. So here's our flat surface and here's our angle. That's a pretty low angle. So the sunlight up here, it's not going to be as concentrated. It's going to be a lot less concentrated up here at the top of the planet. So we can see this if we think of Earth's surface as a model of lots of little flat areas. As the light from the sun hits the Earth, let's look at the angle of the flat surface and how that changes. So here we have the sun hitting the Earth, and these are those 4 little areas that are flat. Okay, ray 1, right here, happens to strike the Earth exactly perpendicular to the surface. So it's at a 90-degree angle. Light ray 2 doesn't strike perpendicular to the surface because the sun is farther north. The solar angle, when compared to Earth's surface, is about 60 degrees. So if we made that into a diagram, we'd have our line here, and that is the same as this part right here. And then that sun's light would be coming in at about 60 degrees. That's about there-ish, maybe a little bit higher. Okay. So let's look at the other 2 rays, 3 and 4. So 3 and 4 are even smaller angles, maybe 45 degrees here and 30 degrees here. So as we go farther north, that solar angle gets lower All right. The white spots on this particular depiction of the globe represent how light beams spread out on these locations on Earth. So the energy from the sun is distributed over a larger area when it hits Earth's surface at an angle. And we saw that with the flashlight demo, where when it was straight up and down, it was a pretty bright circle. But as we tilted it, it got elongated, had a greater area, and there wasn't as bright. So it didn't have as much of a concentration of energy. So as you go farther north or south, you can see that the light spreads out into more of that elongated oval. But at the equator in the middle of the planet, it's pretty bright and circular. The other way to think about it is it happens when you go east or west too. So you can see as we go to the east, or the west rather, it gets elongated, and the same thing going east. So what does that mean? It means in the morning and in the evening, the solar angle is low, so the light is spread out over a larger area. That's why it's not as bright in the morning and the evening as it is in the middle of the day. But in the middle of the day, the sun's energy is most concentrated because the sun is right overhead at a high solar angle. Okay, so why is it warmer in the summer? We talked about solar angles. The greater the solar angle, the greater the concentration of radiant or sun energy. Light shining from directly above is the most intense. Light coming at an angle is less intense, less concentrated. Almost all of the energy coming to Earth is solar energy. Light is absorbed by the land, water, and air and converted to thermal or heat energy. It's hotter in the summer because our hemisphere is tilted toward the sun. Here's a picture of the Earth tilted towards the sun in the summer. You can see that the northern hemisphere is tilted towards the sun if the sun is out here in this little space. So the sun's light hits us at a higher solar angle than it does in the winter when it's tilted away. So this is winter down in the southern hemisphere, and you can see it's tilted away from the sun. The higher solar angle delivers more radiant energy from the sun, which is turned into heat energy. And that is why it is hotter in the summer.